Recording now. All right, this is a video solution for problem number 2 for the exam, for exam 4. This one, and this is where it's actually confusing because it's not super clear. So I don't want to lose points because of that. But from what I'm understanding, the ice cube is in the water and it's level and we have ethyl alcohol above. The only other reason or only other thing about this would be that you would have the ice submerged in both of the fluids. But the question, I don't know if it's even clear about that. It's flush with the ethyl alcohol layer. It doesn't specify if it's submerged or not. So I'm assuming it's not. I'm assuming it's level, which might throw off my answer, but I don't care because I think that's how it's supposed to be worded. I think it's confusing that it's not that worded clearly. So basically it says that the 20 millimeter side of ice, so if you convert that to meters, you get 0.02 meters. And then if you cube that, you get the volume of the ice, which is 8.10 or 8 times 10 to the negative 5th meters cubed. That's a cube. That's not very clear. It looks like a squared. So basically on the ice here, we're going to have the weight of the ethyl alcohol, the weight of the ice, and then the buoyancy force, which is keeping that ice suspended. And the sum of the forces which is the buoyant force, needs to be equal to the force of the ethyl alcohol plus the weight of the ice. I'm saying force here, it's really the weight. It's the same, I don't know, fetch. That's me writing that again, so it makes no sense. Anyways, we know the buoyant force is equal to the density of the fluid that it's suspended in times the volume of the fluid displaced times gravity. And they told us that the density was 997. Where am I coming up with that? Where is that number coming from? Is that the density of water? Oh, that's the density of water. I'm an idiot. So 997 kilograms per meters cubed is the density of water. I looked this up online. It could be 1,000. I don't think I should be docked for that. And then this is the volume of the fluid that was displaced because it's the volume of the ice cube. And then this is gravity. So you get the buoyancy force is 0.7816 newtons, right? So now we're going to find the weight of the ice. So the weight of the ice, we have the density is 917 kilograms per meters cubed. That was given. If we times that by the volume, we'll get the mass. And then you times the mass by gravity, and you get the weight of the ice, which is 0.7189 newtons. Okay. And then now here's the tricky thing. We got to find essentially the weight of the ethyl alcohol. So if the ethyl alcohol is being pushed down on this, the weight force, well, then I guess the weight of the ethyl alcohol will be pushing up is the same as the normal force of the ice, we could say. So if you say 0.02 meters, which is the length of one of our sides, times 0.02 meters, which would be the width, and then times it by this thickness T, that should give us our volume, right, of the ethyl alcohol, okay? We know its density. So the density of the ethyl alcohol is 806 kilograms per meters cubed. If we multiply this by this thing we found up here, and then multiply that by gravity, we should get 3.1595 times T, which is the thickness, right? And now plugging in our equation back to here, and this thickness is what we want to solve for. It's the height of the ethyl alcohol above the ice cube. So going back to our equation where we said that the buoyancy force should be equal to the force of the weight of the ice plus the weight of the ethyl alcohol, we can plug that in now. So we have the force of our buoyant force should be equal to the weight of the ice plus the weight of our ethyl alcohol, which we said was this. So now we're going to solve for the thickness. You just subtract this over and divide by 3.159. This gives us 0.01985 meters. Convert that to millimeters. Should be 19.85 millimeters. Should be the answer. Now I know people are going to maybe dock points because I don't know if that ice is suspended. I don't know if it's up or not. I don't know how much of the ice is there. But from what I'm interpreting from the question, because it's not very clear, is that this ice is level with the water. That's what I'm going with because that's what it sounds like. And then your answer should be that the ethyl alcohol sits 19.85 millimeters above the top of that ice cube.